Our next question is a pretty interesting problem. We are given that three normals are drawn to the parabola x square is equal to 4y. These three normals are cut by the line y is equal to 2 in 3 points whose abscissas are in AP. We need to prove that the slopes of tangents at these three co-normal points are in AP. Now this question may look long and pretty difficult, but if we go step by step and use the basic principles of parabola, then it is not so difficult problem. We are given parabola x square is equal to 4y. Let us differentiate this to get what is the slope of the tangent. 2x is equal to 4 times dy by dx. So slope of tangent is equal to x by 2. X square is equal to 4y. Any general point on this parabola can be taken as 2t comma t square. So on putting x as 2t, we get slope of tangent is equal to t. Hence the slope of normal will be equal to minus 1 upon t. Hence the equation of normal can be written as y minus t square is equal to minus 1 upon t times x minus 2t, and we are given that the normal is cut by the line y is equal to 2. Hence putting y equals 2, we get 2 minus t square is equal to minus 1 upon t x minus 2t. On simplifying, we get 2t minus t square is equal to minus x plus 2t, or rather this is t cube. This 2t and 2t gets cancelled and we get x equals t cube. Hence the abscissas of the points are t1 cube, t2 cube and t3 cube. We need to prove that the slope of tangent at the three co-normal points are in GP. That is, we need to prove that T1, T2 and T3 are in GP. That is, T2 square is equal to T1, T3. And the information which we have is that we are given that the abscissas of the co-normal points, that is T1 cube, T2 cube and T3 cube, are in AP. That is, 2T2 cube is equal to T1 cube plus T3 cube. That is, T1 cube plus T2 cube plus T3 cube is equal to 3T2 cube. This is our first equation. Also, our equation of normal was y minus t square is equal to minus 1 upon t times x minus 2t. That is, yt minus t cube is equal to minus x plus 2t, or t cube plus 2 minus y times t minus x equals 0. Now this is a cubic in t having the roots t1, t2 and t3. Very obviously there is no term of, or there is no coefficient of t square. That is, the coefficient of t square is 0. Hence we can say that the sum of roots taken one at a time, that is t1 plus t2 plus t3, is equal to 0. And one important property we know that if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is 3abc. Hence t1 cube plus t2 cube plus t3 cube is equal to 3abc, that is 3t1 t2 t3. This is the second equation. On comparing the first and the second equation, on equating the values of t1 cube plus t2 cube plus t3 cube, we get 3t1 t2 t3 is equal to 3t2 cube. that is T1 T3 is equal to T2 square, and hence T1 T2 T3 are in GP. Here in this problem we have seen that this was a pretty big problem and it appeared to be a difficult problem, but we have not used any special formula, any special theorem. We have just used the simple concepts of the basic principles of parabola, and hence proved that T1, T2 and T3 are in GP, which is our final result that we needed to prove.